Since I was 16, I've been a huge space nerd, and so I was looking through the Department of Earth and Space Sciences specifically for space science researchers.
We have the Advanced Propulsion Laboratory, which is run by Robert Winglee. Plasma laboratory. This is where all of the plasma work happens. The work that we're doing, especially as it relates to the Ducati funding, is particularly working on thrusters, a propulsion system for a small satellite. And when we're talking about small satellite, specifically, we're talking about something maybe a shoebox size. So the small satellites that we're interested in particular are called CubeSats. And CubeSats are really lauded as an up-and-coming way to put anything and everything in space. And it's really opened up, especially low Earth orbit, so right around the Earth, as a test bed for universities and for small businesses that weren't previously able to come up with the capital to launch big satellites. Our two main industry partners are Eagle Harbor Technologies and Aerojet. The deliverable that we're looking to hand off to our industry partner is a flight-tested working propulsion system that would take up maybe 8 by 10 by 10 centimeters.
Originally, when I joined, I started working on the CubeSat project, and so I was in charge of coming up with the orbit that we would use once we send out the CubeSat.
I'm an undergrad in electrical engineering. What we contribute to the project is that we bring the knowledge of power generation and control and analysis to the group. We design the solar panels. We calculate and analyze how much power could be generated during the orbit and during certain maneuvers that the CubeSat must be able to do.
My role here is to develop a K-band communication system that will fly on the CubeSat along with a reflector array antenna. For industry to do something like this, they have a lot more overhead than I have here.
When we have flown this thruster, they may actually take it and then market it as a flight-tested thruster that other CubeSats could then use.
One of the things that CubeSat has already helped me do and the research that I've been involved in is that in January I'm going to be starting a co-op position at Planetary Resources in Redmond, Washington. So I'm already, because of my involvement with CubeSat, I already have the chance to get involved with an emerging industry.
And we really hope that at the end of this, the development of this propulsion system for small satellites will enable both industry and science to do a lot more. Maybe if their small satellite can stay in orbit for twice as long or can change orbit, what will that enable? And that's something we're really excited in looking at. We're really excited in being a part of the process of making that happen. And so something that we've built will be put into space.